In this video, I'm going to explain application 3 that includes both series and parallel grouping. As you can see, this is a battery showing the positive and negative terminal connected in series to a lamp L1. Then it's connected to a parallel grouping of two lamps L2 and L3. And from the other side, this whole grouping is in series to the battery, the whole grouping. But L3 and L2 are in parallel with respect to each other. Now represent the direction of a flow of current in each branch of the above circuit. We usually represent the direction of flow of a current by using arrows. As you can see here, I showed that for the main circuit, the current is flowing out of the positive terminal of the battery. Then if it flows through L1 until it reaches this point, that result that is branched, or that's connected to two branches, one which includes L2 and the other includes L3. So I'm showing here the direction of the current flowing in each branch. Now deduce the intensity of I2. I2 is the current that passes through I2. The solution is by law of uniqueness of current in series grouping, I1 equals I main, because the current that comes out of the positive terminal of the battery has only one pathway, so it doesn't change its intensity. It's not distributed among certain number of branches, so it comes out of the positive terminal and passes directly through L1. So I1 equals I main. Here you have to mention the law of uniqueness of current in series grouping, then write the rule I1 equals I main. But they are asking us to calculate I2. So what is the relation now? We have here I1 flowing out of the lamp L1, then it comes to this point and has to be distributed into two branches. It is distributed into I2 and I3. This grouping here is parallel grouping. So by law of addition of current in parallel grouping, I1 is equal to I3 plus I2. Doing the substitution here, we already proved that I1 equals I main. This means it's equal to 2 ampere. So 2 ampere is equal to 1 ampere plus I2. 1 ampere, move it to the other side, it becomes minus, we have to change its sign. 2 ampere minus 1 ampere is 1 ampere. So I2 is equal to 1 ampere. Now calculate U main. By law of uniqueness of voltage in parallel grouping, U2 is equal to U3. So, but this whole grouping altogether, if I take it as one package, okay, it's going, we can see that it is in series to L1 and to the battery. So, by law of addition of voltage in series grouping, U main is equal to U1 plus U2, because U2 is equal to U3 is equal to U of the grouping here. So we can say that U main or U battery is equal to U1 plus U2 by law of addition of voltage in series grouping. You have to mention the law. Now doing the substitutions, 3 volt plus 1.5 volt is equal to 4.5 volt.